So I want to kind of introduce you to derivatives and the terminology that goes with derivatives. But derivatives are essentially half of calculus, or at least calculus 1 topics are split into differentiation, which deals with derivatives, and then integration, which deals with integrals. And as you could probably guess, those two major topics, are the two big problems that we've been talking about. So the differentiation, differential calculus is called sometimes, deals with derivatives, which deals with finding the slopes of curves. One thing you want to keep in mind when we're doing all of this is we're going to be doing this from the angle that we're trying to find the slope of a curve in a coordinate plane, but those slopes have real interpretations in applications problems. So whether we're looking at the position of a particle and taking a derivative to find the rate of change of that particle, which would be interpreted as velocity, or we're looking at the flow of water or the amount of water in something and taking the derivative and interpreting that as the flow of water into or out of that something. These things have physical interpretations. So when we're finding slopes, these slopes can be interpreted in other ways, and we'll spend a good portion of time talking about the applications of derivatives and what they actually mean in those applications. So to introduce you to derivatives, I want to talk about what a derivative actually means. And we've already hit this. We've already talked about what it means, we just haven't called it a derivative yet. So a derivative essentially tells us the slope of a curve or the slope of a tangent line to a curve. All right, now if you're going to draw this picture, you don't have to draw it exactly. I'm just putting it up there for an example. So let's say that I pick a point on this curve, and I want to answer that tangent line question that we asked, which is essentially, what is the slope of the tangent line at that point? And let me get this right here. So the tangent line question asks, what is the slope of this red line right here? At this point where x, we'll just say x is negative 6 for the purposes of our discussion. So what is the slope of this tangent line to the curve at x equals negative 6? Now a lot of times we'll just say the slope of the curve. A curve itself actually doesn't have slope, but we'll use that phrase still, the slope of the curve, to actually mean the slope of the tangent line to the curve. All right, so only a line can really have a slope. So what we're talking about when we say the slope of the curve is the slope of the tangent line to the curve. And you can kind of visualize the slope. It's pretty easy to do if you just take a little piece here and there. You can kind of visualize what the slope's going to be at any piece, like there or there or there. At this point, you could definitely say whether the slope is positive or negative, I think, at any point, or 0. And we'll use the derivative to be more specific and talk about, well, how positive is it, how steep is that curve. So we've talked about some methods that we can use to find this slope. And what we're going to start doing today is put this together with not just this point, but find the slope of every point along a curve. And so when we talk about derivatives, we're not talking about the derivative necessarily at a point, but usually we're going to talk about derivatives as a function. So we are going to come up with a function for maybe a curve like this that would give us the slope of the point, the slope of the tangent line at every point on the curve. And so we're going to put a function together with its derivative and look at the relationships between those. So if we were going to start doing something like that with this, we could say, okay, well, the slope here is, what would you guess that is? About what? About 3 maybe? Somewhere between 2 and 3. So in green here, I'm going to plot the slope. So the slope would be about 3. So this would be a point on the derivative curve. If we go to a point like right here, what's the slope right there at that maximum? That's going to be 0. So we would have a slope of 0. So our derivative would be 0 at that point. So the derivative is just a way of describing the slope of the tangent lines to the curve. What would be the slope right here? It would also be 0, right? Now what about between these 2 points? What would the slope be? It would be negative something, right? So maybe somewhere in here the slope would be like negative 1. So we could plot that there. And what's going to end up happening, and I'll show this to you later, these points are going to tie together into what we call the derivative. So that we can take this derivative function and plug in an x value to figure out what the slope of the tangent line is very quickly. All right. We could do that with any type of curve. When we have something like this is a cosine curve, stretched a little bit in two ways. But when we have something like this, we can take derivatives and find the slopes of the curve at more than one point. The derivative for something like this may seem trivial, but this curve, we'll call it a curve even though it's a line, it has a derivative, and it's a line, so it's really easy to compute the derivative. We don't have to do any of that calculus stuff to compute the derivative here. We could compute this derivative with pre-calculus, in fact, Algebra 1 stuff. What would be the derivative of this curve at any point? Yeah, it would be 2, right? So if I pick a point right here, the slope at that point is 2, at least the slope of the tangent line, which just happens to be the line itself. And so the derivative at that point would be 2. And if I do that across, if I plot the derivative at every point, or every x coordinate, what are we going to end up with? A horizontal line, right? So we get the line y equals 2, and this would be, this line would be the derivative of this line. And what this tells us is, for any x value, I can put, say, 4 in for x, and the derivative at 4 is 2, so that tells me that the slope of the curve at that point is 2. Does that make sense?